All right, so now we're going to look at the real world applications of this. So we've got the owners of a circus are planning a new act. They want to have a trapeze artist catch another acrobat in midair as the second performer comes into the main tent on a zip line. That's a little intricate. If the path of the trapeze can be modeled by a parabola, the path of the zip line modeled by a line, at what point can the trapeze artist grab the second acrobat? So if you notice, with our two equations here, they're both already set equal to y. So since they're both solved for y, we can actually set them equal to each other. So I can say 2x plus 12 is equal to 1/4 x squared plus 16. Since they're both equal to y, I can set them equal to each other. So one thing I did to make life a little easier for myself, I didn't like that 1/4, so I multiplied everything times 4 to get rid of that fraction. So now I have 8x plus 48 is equal to x squared plus 64. So now if I want to solve this, I move everything to one side of the equation. So I'll subtract the 8x, subtract the 48. So I end up with x squared minus 8x plus 16 equals 0. Lucky for me, this factors. It's a perfect square. It factors to get x minus 4, which again is a perfect square. It's x minus 4 squared equals 0, which means that x minus 4 is 0 and that x is 4. So now I know my x coordinates, can plug it back into one of these equations. So I'll go ahead and take the equation of the line. That's the easier one. Y equals 2x plus 12. So y is going to be 2 times our x value of 4 plus 12, which means that y is 20. So our trapeze artist can catch our other trapeze artist at the point for 20.